we're in this very interesting moment. Like, on the one hand, agents are amazing. They're also terrible because what the heck are they doing? We really need our code review processes, our guardrail processes to be more efficient. We need a practical way to get through checking that we're actually getting what we want, and we can't really trust that we are going to be getting what we want. So hello, so welcome to Tessl. So as mentioned, so I get to work in this lovely office, but it's always such a pleasure when we have a bunch of people come by. Can you hear me? My name's Amy Heineike. I'm a researcher and engineer here, and I've been helping build our internal software factory, and then I've also been spending a lot of time evaluating what agents are doing and building different tools that we're putting into our product. I'm so delighted that I'm doing this talk right after Dave, because I feel like so much of what you talked about resonates really strongly with what I'm going to talk about. And I'm going to talk about the rise of the harness engineer, and this is kind of the skill set that you exemplify, basically, and thinking about how, for a lot of us, this is changing what our jobs are going to look like, right? So agents are doing more and more coding, and we need to start thinking in these new kinds of ways that aren't quite the way that we used to work, but what unlock us to make the most of agents in this world. So I'm going to start with a few observations that are probably obvious to everybody here and repeat some of your ideas. So first of all, the agents got pretty great and we're all using them a lot. So there's lots of studies on this. There's a great one from Pharos AI where they showed this incredible rate of AI coding tool adoption. And I think we went from last year, it was like very spiky, the adoption, and now we're seeing the vast majority of code in many organizations is actually AI authored. We're also seeing the benchmarks getting completely saturated. So if you can define a task, you can ask an agent to do it, you'll normally find that the agent can complete it. And we're finding it hard to write benchmarks that are kind of task-driven that agents can't complete. When we stare a bit closer, though, I mean, we start to see some cracks. So agents can do tasks, but do they do it in a way that's maintainable? Do they do it in a way that leads to kind of health of the code base over time? We have more questions there. So this is the same report that looked at adoption of AI. This staggered me, actually. Like, the number of bugs that they're monitoring has jumped up. The number of incidents has jumped up. And this resonates very deeply because I don't know about you, but when you use software these days, it feels like everything is just a little bit crunchier and like cracks around the edges. We're in this very interesting moment. There are some new benchmarks. This one's called Slop Code Bench, where they try and have like a long-running agent do a series of tasks. It doesn't know what order it's going to have to do the tasks in, and so it needs to have built in a nice incremental way to be able to pull it off. And as soon as you do tasks like this, you see much, much lower scores. So the agents are struggling a lot more. I think there's a kind of this idea, I think that a lot of us are also noticing, like, in a way, the agents are just getting better and better, and so you can think like, oh, better models will solve all of this. This chart, I don't know if you've seen one like this before, this is the Pareto frontier, and so we basically plot how much it costs to use an agent versus kind of an intelligence score. And so if you draw the line across it, you get the best value model for each level of intelligence. What's crazy about this is that the left-hand scale is kind of a linear one, so we're seeing kind of incremental improvement. The bottom one is a log scale, so there's 100x price difference between the left and the right, and the green line in the middle is 10x. So it's 10 times as expensive to run Fable 5 as it is to run GPT 5.6 Sol on a medium reasoning. So even in cases where the better model can do the task, we're seeing like that sure is an expensive way to solve problems. And if you're in an organization where you're starting to have a lot of throughput of agents, we become more and more aware of this. I think we had 600 PRs close this week, like at Tessl. We're like fairly small organization. Like we're talking about, if you've got a lot of code going through, we need to think about this carefully. We think a lot about skills here, so we've launched a load of products to help people manage skills in their organizations, govern them, optimize them, share them, understand what they've built. And we built a benchmark for skills. So we took 1,000 skills that we found in different open source repos. We built tasks that would use the skills, and then we got agents to do those tasks with and without the skills, so we could kind of compare how well they behaved, and we graded both how well they finished their tasks and the ability of them to follow all of the instructions in the skill. So did they get the thing done, and did they do it exactly the way that the skill defined? We found a few really interesting things. So you can, and I'll show you some more charts in a second, so you can drive agents quite dramatically with skills. You can get them to approach tasks in a very different way, so these are great tools. A well-defined skill will mean that you can get the same level of task success with a much cheaper, smaller agent. So there's a path to kind of making better use of the agents that we have. But also we find that instructions are not followed very thoroughly by agents. So what we were able to find is that task completion rates were very high on all of these tasks that we studied, but only about 70% of instructions from skills were getting followed on average. So there's a big gap here. So this is comparing instruction following across a ton of different models, and there's a big range in this. So even the best models are ignoring a lot of the instructions that they get. So we classified all of the different skills that we'd found, and there's a big difference. So in some domains, you can see that this kind of you see very different levels of kind of instruction following than we do in other domains. So what this chart is showing is kind of the gray bar is how many of the instructions in a skill an agent would have done anyway. So some stuff agents are great. They're kind of doing whatever they, they've learned some best practices. But then the green bar is how well they adapted to work the way that they were told to work, and the bit on the end is how much they didn't do. So the steerability question, I think maybe the labs have been slightly under-rotating on steerability and over-rotating on task completion, and we feel this when we try and get agents to do the things that we want them to do. So we're in this very interesting moment. Like on the one hand, agents are amazing. They're also terrible because what the heck are they doing? We really need kind of our code review processes, our guardrail processes to be more efficient. If we're going to have rocket boots, if we're going to generate tons of stuff, we need a practical way to get through checking that we're actually getting what we want, and we can't really trust that we are going to be getting what we want. And so this is an incredible and interesting moment. I think all of this points to the fact that engineering really matters, and it matters more now, not less. So I think in the past, when we were doing a lot of engineering, when we were building code bases, we could kind of accumulate knowledge, we could share knowledge, and we could kind of build incrementally and rely on individuals kind of reviewing PRs and teaching each other and kind of training each other as the way that we could kind of steer and shape the code that we were writing, the software, the engineering we were doing. And now we're letting agents run at it. A lot of that needs to become more explicit. We need to think about how do we encode this into our practices in a way that will work and kind of survive the agents. I'm seeing like 3 kind of big skill sets that are really important. And they're a little bit different from the ones that maybe we had to really develop previously. So one of them is systems thinking. One of them is analytics. And then the other is kind of risk and operations, reasoning about those. So what does that mean? So systems thinking, when we think about what we want from as we build code, as we kind of ship new features, some of what we want is specific to the task we're doing, and some of it is actually an expression of kind of a general principle that we want to kind of keep on being true. And I think this kind of resonates with the prompts that you were talking about. So if we can start to identify invariants, so if we can think at kind of a systems level about things that we want to be true in our code, then if we can capture these and enforce them, then we've got more of a chance of kind of keeping consistency, keeping the quality bar high. So what does this look like? I think things like design systems are an example of invariants. So rather than kind of designing what an individual page looks like, it might be kind of talking about the types of layouts that we want, the type of brand voice that we want, the types of components, what buttons look like. This could be on architecture, so it could be how we want our code to be structured. It could be on what libraries we're using, opinionated views on which particular styles we want them to be, how we want to call and use those libraries. It could be opinionated practices, so it could be, how do we want errors to surface through our stack? How do we want things to be named? How do we want our data flow to be through the stack? So these are all things that, like, in the past, we would have expected that was probably a code owner who had a instinct or developed a theory of this. Like, you could ask them to draw you a systems diagram, or like an architecture diagram, they'd draw you a picture of it. You could sit down with the designer, they would show you the Figma files, and you could ask them to go and kind of check PR by PR, hey, does this kind of match? But now we need to actually capture these and start thinking about them as key parts of the system, as kind of prompts or definitions that we enforce and encode. So it's now actually possible to enforce these kinds of patterns in a bunch of different ways. So we can write skills that describe what we care about and give them to our agents. So we can make sure that we've kind of tuned in exactly the description of what we're expecting. We get that to be loaded at the right time. We can put deterministic checks into our CI, so linters. You know what, I hadn't even heard of AST-grep probably, 4 or 5 months ago, and now we seem to be talking about it all the time, so you can write kind of deterministic rules, and actually agents are really good at this, so I think maybe in the past it was a pain to write this kind of stuff, but now it's really easy. So you can enforce patterns and check that, code only imports from other code, and certain libraries never used, or certain names are never used. We've expanded this to look for, we have this concept of verifiers, which are very narrow rules that we can kind of measure on every single file with a quick agent to look at them. So we can expose more of these tight rules that we want to apply everywhere. And then we can do agentic code review. So we can say kind of broader prompts to agents of the types of rules that we want them to follow. I want to dig into this a little bit more, so this idea of guardrails. So we've been collecting more and more of the patterns that we find, especially from code review, where we see agents making the same comments over and over again. We want to make sure that we can effectively turn them into a big checklist, every single rule that we believe in, and then we can kind of guarantee that they're getting followed in every single PR in a really repeatable way. And I think it's been fascinating to me, but perhaps this is the researcher, like model tinkerer of me, I don't know. I think, as models have been getting better at coding, they're also getting better at judging. And so if you have very clear criteria, you can get very clean judgments. And this is a really powerful tool that we can be using. Okay, so we are going to be thinking more and more about the system and reasoning about it. But I think to Dave's point earlier, the way to really reason about systems is to think about analytics. And I think, it's not maybe what we were doing as engineers as much before, of thinking that we needed to think analytically in order to unlock engineering. But what's cool is as we automate more of the code generation processes, we have more and more data that we can look at. And there's a bunch of signals that we can be using. So agent logs are super fascinating. Has anyone here just spent a lot of time reading coding agent logs? Yeah, okay, I'm getting a couple of nodding heads. I'm not the weirdest one. That's very reassuring. There's sometimes if you read them, you see agents will just spin in a cycle and get confused. So we can spot where are they wasting time. We found there were certain tools that our agents got really super confused about. Actually, linear, it turns out the API, our agents for some reason always got confused about, so we ended up writing like a simple kind of CLI that could call the linear API that we could observe that it was finding much easier. So we can look at agent logs, we can see what problems are in agent logs. We can look at PR comments, so we can see what things are they doing wrong over and over again. And then they might be things that we want to turn into guardrails or lint rules, or they might be things where we need to just tell the agent ahead of time, like remember to follow this rule. We can look at architecture that's emerged in the code base, so we can run complexity analysis on the code base. We can see, are there places where it's turning into spaghetti, where everything's importing from everything? We can run mutation analysis on our tests, where we can say, are there parts of our test suite that aren't actually earning their keep? They're not actually useful tests. Are there gaps in part of our testing coverage? So we can use all of these signals and turn those back into hypotheses that we might build about where the agents are going wrong, and into kind of choices about new invariants that we might want to describe, name, and then figure out how to enforce so that we don't have to worry about that again. So these can be manual review, so you can grab the data and stare at it for a long time and then pontificate about the ideal architecture. They could be automated loops where you have an agent go and do a quick check of things and spot, hey, something was going wrong here. Maybe we should strengthen something. So analytics is a super important new way to start thinking, to draw on. And the next one is kind of risk and operations. And I think this has come up a couple of times. What's interesting is that we have a load, we've got all these new capabilities. They work differently than they used to do. We've got all of these controls, and we need to be able to reason about, is it good enough to let it kind of run on its own? Is it not good enough to let it run on its own? Like, how much review do we need? And so I feel like the kind of ideas about risk, what our risk policies are, suddenly need to become much more fine-grained, and they need to be something that more and more of us are talking about and using. So one thing we've thought a bit about at Tessl is we have this kind of ladder where there are actually quite a lot of our PRs auto-merge. So we have certain parts of our code base where we're like, like the research code base, for example, is free for all. You can just merge anything you like. There are absolutely no rules here. Some of our internal tooling is auto-merge. So we have like hundreds of PRs going through all the time. Nobody looks at any of them. And then other parts of our code base are, you absolutely need an engineer to look at it. So whoever's kind of working on the feature, who's steering it through, they need to go in and kind of do that final merge. There are a few very kind of higher leverage parts of the code base where you probably should realize that you should ask somebody who's thought about it before rather than ramming something through. So thinking about what these levels of risk are, thinking about which parts of the code base they are, trying to kind of codify that into rules that then go into your GitHub settings and change what checks and balances you put on different parts of the code base. This is suddenly really important. So this is all the kind of harness engineering skill set, I would say. And I think for most organizations, we're either going to have like a few of our Daves who are going to live this, right? They're going to think about invariants, they're going to think about analytics, they're going to think about risk, they're going to think about these policies. I think it might also be that for many of us who are working in engineering, this becomes more and more of where we spend our time. And it's actually quite a big shift to think of spending a bunch of our time like this, as well as spending it thinking about the features that we want. So this is kind of how we're going to be tenders and gardeners of our our code and our software alongside kind of builders who are thinking about shipping. So I've mentioned this quickly. So at Tessl, we've been building a software factory internally. So I think like 95% of our code went through this factory this week, and over the last month, we've been at over 90%. And we're also starting to ship more of these components. So if you want to get started and tinker with stuff, you can install the Tessl CLI. And we're starting to put out more content now about the Tessl agent that you can use to kind of talk to and kind of see what tools there are so you can go play with it. So part of the vision of the factory is that what happens is more of your coding goes into kind of remote execution coding agent that you're loading up with all these kind of skills and context. You have a bunch of guardrails, so these kind of deterministic checks, verifiers, things that are in CI. You've got kind of automated code review. You may have this kind of triage gating step of, okay, can we reason about how much risk we need to apply, how much care we need to apply? And then all of this then has these update loops where we're going to monitor what's going on. We're going to learn from that about how we can improve each part of the stack. So yeah, if you want to tinker, please feel free to come and chat about it. But I think that the big thing I want to you to take away from this is this role of the harness engineer, these new skills, this new way of thinking that I think more and more of us need to embrace. And I wanted to leave you with kind of one set of ideas on what are things to get started. So if you're not doing this kind of job full time, where you would start. So I think the first exercise is thinking about this invariance. Like for the code that you're working on, could you describe some of the invariants? I'd say it's quite an uncomfortable thing to start doing, actually. It's like working out what precise rules you would actually claim should always be true across your code. It's worth just trying it out, going through that exercise. Think about how you could make at least one of those become a CI gate that you apply, and then see what happens with it. So think about, did that start catching this problem that you were aware of, that you cared about? Like, how often is that thing firing? And then I think the last thing is to try out thinking about building a data set. So again, it turns out the agents are great at this. Tell your agent to go grab the last 50 PRs in your repo and ask it to summarize what it observed about what was going wrong. So what was repeatedly being said by people in comments, or what repeated errors there were, where was it tripping up and triggering CI failures? And then use that to think a bit more about, okay, what were the invariants I cared about? What could we have improved? Okay, that's it. Thank you.
Really interesting. Does anyone have any questions at all?
Cheers. You talk about this software factory. What does the input look like? So like the engineers day to day, you're saying that most of the software that was written this week was done by agents. What's the input? Is it just an engineer writing a prompt as part of like a GitHub issue? Is it a spec?
Yep. So our prompt is a linear ticket. And we have some skills for writing linear tickets where we have described in those skills kind of how much detail to put in there and when to push back and ask for more detail. We've got a number of ways that you can get stuff into that linear ticket. So I will often be working in like Conductor, and I'll set up an agent session where I'll be like, I'm thinking about this kind of thing. And then maybe, do some exploration with an agent, and then when I'm ready, then I might say, okay, read this skill and fire off the ticket. As soon as it lands in linear, we've got an orchestrator that's watching, and it will pick it up and push it through all the steps. We've also got some Slack bots where you can we call it the Dark Factory app, Dark Factory app. We should make a ticket for this, and it will have seen the Slack thread, and it will make a ticket, and then that's what will be the starting point.
Thanks, Amy. I was actually going to ask Dave the question, but maybe you'll be able to answer this as well. How do you prevent whack-a-moles from happening where, in a PR, when it gets long, there are opposite things said, and then we forget, and in the world of agents, it's very easy for the agent to agree on the opposite things. And before you know, your prompts and skills have all been modified with contradictions. So first of all, if you have a software factory or dark software factory, you don't know where these contradictions have happened and at what point it's gone, in the whole wrong direction. So how do you, so for two questions, how do you watch for this in a non-software factory process as well as in the software factory process?
Yeah, so I think code review is hard. It's hard to trust an agent exactly when it does a code review. It's hard to know whether all the findings are valid. So it's really important that nothing thinks that it's authoritative. So you don't want to have prompted your coding agents to say, fix all of the issues. You want to prompt them to say, consider the issue, consider these findings and decide whether to respond to them. You might also need, so you basically need them to be able to weigh up and then give up on it, I would say. So that's the simple answer. I think the longer answer is, again, think about the system as data. So I think I don't think any of this is easy or we know the answers to it. And so I think what we have to be is pretty vigilant about thinking and spotting problems. And as soon as we've spotted a problem, thinking, how can I turn this into an analytics query? So can I create a query where I'm getting a distribution of like how many comments are getting posted and how much back and forth there is? And then if I'm monitoring that, if I make changes to how I've prompted my agents, can I see if that's improving or not? And then, you have to experiment. Again, the scientific method, try stuff out and try and work out what's hanging up the agents. But definitely the starting point is that none of these things are, none of them are kind of true forever and need to be absolutely implemented because you'll go crazy. Yeah.
Thank you. It's very insightful. The question I have is those skills in invariant, they are reducing the reasoning cost. So that's A. And in one of your slides, you were saying the models are following 70% of the skills, right? And then they deviate the rest 30%. Is it the way the skills are written, which is actually leading to the 30% miss, or there's something else at the play?
Yeah, I think there's a few things. So actually, in our benchmark, we made the agents read the skill. In real coding, you don't make, unless you've used the command. So agents ignore skills all the time, so they just won't even read them. That's partly a problem of the descriptions in the skill, and so actually Tessl have got a feature in the CLI called Tessl Review that you can pipe a skill into, and it will help you check if you've got good disclosure in there. So you kind of have to write the description in a skill as like an advertisement to the agent of like, hey, you should read me, but you don't want to make it too exciting because you don't want the agents to read it when you don't want it to read it. So yeah, the first problem is getting the agent to read it at the right time. The second one is I think what we see with agents, so the 70% was like, of all of the instructions in the skill. So we take a skill apart and we write out each instruction, then we see how many of them are followed. So having analyzed a lot of skills, there are a few things that go wrong. One of them is that we write overly prescriptive skills with tons of instructions in. And if you go back and sometimes a good exercise to do is to just read the entire prompt you're giving to an agent and think about it. And it might be that we've just overloaded the agent with so many skills and rules and context that it's like, I don't know, I'll do this bit. This seems like too much of a faff. Sometimes it's really easy to accidentally write two skills that contradict with each other. And then, again, the agent's like, I don't know, I guess I won't do any of it. So some of it is on the authoring side. But I think also, I don't know, agents get tired. Bless them. I don't know, it's a mystery. It's a bunch of numbers in a massive matrix, and who knows what's happening inside of there. So it's useful to be aware really carefully of where it's easy for the agent to get it right and where you're really having to push the agent because maybe it's against something that's been heavily trained into it and it's just like not going to go there. Yeah.
Sorry, we've run out of time, unfortunately, but Amy will be hanging around after as well
Absolutely,
for
yep.
for 10 minutes if there's any more questions. Lots to think about there. So yeah, thanks very much.